now we're going to look at some examples of problems involving what we just learned concerning molarity. So there are three examples here, and what I think I'm going to do is dedicate a video to each of these, all right? So the first one says, what is the molarity of a solution in which 333 grams of potassium hydrogen carbonate is dissolved in enough water to make 10.0 liters of solution? So what I'm going to do is I'm going to open up this writing application here so we can do the problem here. Excuse me. So the question is asking for the molarity, and the question gave you the mass of the potassium hydrogen carbonate. So the mass is 333 grams of potassium hydrogen carbonate, and we need the formula for that. That is KHCO3. All right, and the question also gave us the volume, which is 10.0 liters. 10.0 liters, that's the volume. V, this is the mass. And the question is asking for the molarity. All right. So remember now, we just learned that the molarity of a solution is equal to the moles divided by the volume in liters. Volume in liters. Now the moles, we're not given, but we're given a mass, right? And we're given a formula as well. So we can use those two pieces of information to get the moles. Basically, to get the moles, we divide the mass in grams by the molar mass. So we have to calculate the molar mass of potassium hydrogen carbonate. So let me do that separately over on this computer right here. So let me do this. So for potassium, it's 39. Hydrogen, it's 1.008. Carbon is 12.01, and hydrogen is 16. So according to my calculation, this works out to be equal to 100.12 grams. And then we divide that by the volume in liters, which is 10.0 liters. And we work that out. So let's work that out. Divided by 100.12, and then divide that by 10. So according to my calculations, this works out to be equal to 0.33 mole per liter, or M. All right. So that's basically how that is done. All right. Okay, so that's a relatively simple example. Let me see here. Let me go back to this. Okay, so I'm going to start